This is 5 Minute Friday on Q Star. Welcome back to the Super Data Science Podcast. I'm your host, Jon Krohn. Today's episode is all about a rumored new model out of OpenAI called Q Star, and it's been causing quite a stir both in the AI community and beyond it. Q Star is reported to have the ability to solve relatively complex math problems that are expressed in natural language, in words. So these are problems like, the cafeteria had 23 apples. They used 20 apples for lunch and bought 6 more. How many apples do they have? Yeah, so if Q Star can solve relatively complex problems like this, math word problems like this, that indicates a significant leap forward in AI capabilities. The Q Star rumors began during the corporate drama a few weeks ago, during which OpenAI fired and then quickly rehired its CEO, Sam Altman. Around the same time, reports from Reuters and an online outlet called The Information linked the development of Q Star to this upheaval. More specifically, OpenAI staff reportedly sent a letter to the OpenAI board warning of the potential dangers this new AI could pose to humanity. Since those reports, however, no concrete evidence convincingly linking Q Star to Altman Gate emerged. And so maybe it was one of many factors that led the OpenAI board to state that Altman was not consistently candid in his communications with the board, hindering its ability to exercise its responsibilities, or maybe it wasn't. Altman did, weeks before his firing, state in public that he'd recently been in the room for a startling new demonstration of a new AI capability, which could have been a Q Star demo. And there is speculation that a power struggle between AGI doomers versus boomers, with Altman in the presumably pro-Q Star boomers camp, and this could have precipitated Altman's firing, but alternatively, it could simply have been petty internal politics that led to the brief coup. With that speculative context explaining why Q Star has generated so much interest, let's now step back from the speculation and look at what we actually know about the Q Star development. OpenAI hasn't released specific details on Q Star, but they have released published work on solving grade school math problems using AI. Critically, this kind of step-by-step reasoning in solving math problems has broader implications beyond just mathematics. For instance, consider a complex math problem where you need to keep a running tally to solve it. This step-by-step process is similar to what large language models, LLMs, use when they execute upon so-called chain of thought prompting. So Google researchers demonstrated that this kind of chain of thought prompting leads LLMs to perform better on not just math, but other complex logical reasoning problems as well. In this chain of thought prompting, the LLM uses its own output as a sort of scratch space, a kind of working memory, like when you're thinking through a problem. And this allows it to break down complex problems into simpler, manageable steps. OpenAI's own published work in this area involved paying humans to provide feedback on 800,000 individual intermediate steps across 75,000 grade school math word problems, creating a formidable training set. They then used a technique where an LLM generates multiple solutions at each step in the solution, while a second model acts as a verifier to pick the best one. Their research shows that this method, when set loose on their big human-generated dataset, can tackle more challenging problems more efficiently. However, not all logic problems can be solved linearly. Some, like seating arrangements at a wedding with specific guest preferences, present what computer scientists call NP-hard problems. These NP-hard problems often require not only exploring many possible solutions, but critically, also backtracking when necessary. Such NP-hard problems bring us to the concept of tree of thoughts, which was proposed by researchers from Princeton and Google's DeepMind group in May. This tree of thoughts approach allows an LLM to explore different reasoning chains branching off in various directions, not just one, not just linear. It seems tree of thoughts is a solid step towards enabling AI to engage in more creative and more complex problem solving. From public statements and interviews, it appears that an even bigger goal for AI researchers like those at OpenAI and DeepMind is to combine the reasoning abilities of LLMs with a sophisticated so-called search tree method akin to what was used in the famous AlphaGo algorithm. So AlphaGo's success in the supposedly intuition-driven game of Go came from its ability to simulate thousands of games and use neural networks to evaluate the best prospective moves from those thousands of simulations and thousands of possible moves at any given point in gameplay. This, at long last, brings us to why this new OpenAI model is called Q-Star, because Q-Star can help us train a model that can do this kind of simulation and prospective move evaluation. While Q-Star is a mathematical term from reinforcement learning literature stretching back several decades, it was popularized exactly 1 decade ago in 2013 when DeepMind incorporated deep neural networks, also known as deep learning, into reinforcement learning to create something called deep Q learning. They employed this deep Q learning to allow machines to excel at playing a broad range of Atari video games. You can check out the hour-long YouTube tutorial with accompanying Python code in a Jupyter notebook that I put together 5 years ago on deep Q learning for all of the mathematical detail. But broadly speaking, the concept of Q-Star within deep Q learning is that Q-Star guides identification of the optimal action a reinforcement learning algorithm should take given the particular situation that it's in. The key takeaway from this is that whether we're talking about applications to Atari video games, or Go, or math word problems, or general logical reasoning, the Q-Star model that OpenAI has now rumored to be working on alludes to the creation of an AI that can improve its reasoning through a sort of automated self-play, playing games against itself. This generates a lot of data, and it also allows the algorithm to explore and learn from a vast array of possible solutions. Critically, this automated self-play would mean expensive, slow humans would no longer be needed to generate vast amounts of training data. And as demonstrated by the startlingly creative moves that AlphaGo makes while playing Go, Q-Star could solve new problems beyond anything included within its training data. That's huge. This is a really big deal toward potentially realizing AGI, artificial general intelligence, a machine that could meet or exceed human ability on any cognitive task, at least someday. More on that in a bit. If OpenAI's Q-Star approach, which blends deep Q learning with LLMs, does scale up to allow generative AI systems to solve complex math and logical problems, this could portend in the relative immediate term that machines could perhaps resolve complex mathematical proofs, define new physics concepts, and assist us with things with technological breakthroughs like nuclear fusion. There are also security concerns then, like encryption being cracked, hence the rumors of Q-Star being linked to OpenAI doomers attempting to push the commercially oriented boomer Sam Altman out. Gaps between Q-Star and AGI, however, likely still exist. For example, while humans can update their mental models as they work through a problem, today's neural networks have a rigid separation between the training and inference phases. Bridging this gap may require another fundamental architectural innovation in AI beyond Q-Star. Now, whether it's Q-Star or these additional fundamental problems that lie beyond Q-Star, one interesting tidbit from all of this is that it appears Dr. Noam Brown, who was our guest on Super Data Science in episode number 569, and particularly the research he was involved with on the natural language negotiation game Diplomacy, which we detailed in episode number 663, it appears that Noam is playing a key role in this transformative frontier research since he recently joined OpenAI. Indeed, Noam Brown tweeted in June that for years, he's been researching AI self-play in games like poker and in games like Diplomacy, and that now he'll investigate how to make these methods truly general. Noam predicted that if we can discover a general version, the benefits could be huge. He says, yes, inference may be 1,000 times slower and more costly, but what inference cost would we pay for a new cancer drug or for a proof of the Riemann hypothesis? And indeed, Professor Jon Krohn, the celebrated deep learning pioneer, as well as the chief AI scientist at Meta, where Noam worked until earlier this year, Jon Krohn tweeted just last month that Q-Star is OpenAI's attempt at planning, and they pretty much hired Noam Brown to work on that. In conclusion, while Q-Star might not end up being the monumental leap towards AGI or the huge threat to humanity that some rumor it to possibly be, Q-star could nevertheless represent an important step towards more sophisticated and general reasoning abilities in AI, far beyond what we have today. The journey to understanding and replicating human-like reasoning in AI is complex and full of unknowns, but developments like Q-star are crucial milestones along this path. Stay tuned to this podcast as we continue to explore these fascinating advancements in the world of artificial intelligence. In the meantime, beyond the Q-star YouTube and GitHub links of mine I already mentioned in this episode, you can get even more detail on deep Q learning by checking out my hands-on deep reinforcement learning video course in the O'Reilly platform, or you can check out chapter 13 of my book, Deep Learning Illustrated. All right, that's it for today. I hope you found today's episode to be both interesting and informative. Until next time, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science Podcast with you very soon.